In this video, we continue our discussion of section 11.5, and we begin our discussion of planes in 3 space. Just before we begin, I do want to show, I have a video here, I'm going to show a picture, or a graph, or not a video, of a plane in 3 space, just in case you have no idea what I'm talking about when I say a plane. Here is a plane in 3 space, so we have our x, y, and our z axis. It's like a sheet, an infinite sheet of paper almost. That thin, it's supposed to be extremely thin. So we actually have 2 planes here. We have our x, y, and z plane, or we have our x, y plane that's flat, the gray one there. And then we also have this plane that I created that's in blue. This app is GeoGebra 3D Calculator. If you have an Apple product, it's free. It also, if you don't have an Apple product, they have a website. It's all streaming. Okay, let's go back to our problem here. So it says we're going to derive the formula for a plane. So a vector that is orthogonal to a plane, that is a new definition for us. This is called a normal vector. A normal vector is a vector that is orthogonal to a plane. This is going to be extremely helpful when deriving a plane. So let's begin. Given one point on a plane, so we have this point, it's on that plane, and then a normal vector. So this vector is orthogonal to every vector in the plane. So we're going to define a specific plane given that point and that. So I'm going to pick another point. So let me try to be pretty formal. Let P, X, Y, Z be any point on the plane. All right, then we can do this. Okay, so we have P naught P. We can make a vector given those 2 points. This vector is going to be in the plane. So if I'm doing that, that is x minus x naught, y minus y naught, and z minus z naught. So take a moment, understand if I pick 2 points that were in the plane and I made a vector, then the vector is in the plane. So P naught P, this vector, is inside the plane. We know, remember the normal vector is orthogonal to every vector in our plane. So I know that if I take P naught P, that vector, this is orthogonal to my n vector, right? The normal vector. That's just by definition of normal. All right, so I picked 2 points in the plane. We came up with a vector. We used its normal vector. I know that they're orthogonal. And then this tells me one other thing here. I know that if I take the vector P naught P and I dot it with n, since they are orthogonal, we are guaranteed that we will get a 0. Now I'm going to use the definition of each one of these to come up with the definition for a plane. All right, the definition of P naught P is x minus x naught, y minus y naught, and z minus z naught. That's going to be dotted with A, B, C. That's just the way we defined n up there to get 0. Now, when I dot 2 vectors, remember we just multiply our components together, each component, and then we add them. So I get A times x minus x naught plus B times y minus y naught plus C times z minus z naught. This is actually standard form of a plane. Let's identify the things that we have. We have A, B, and C. A, B, and C are our normal vector. So it's a vector that is orthogonal to the plane. So as long as we can find a vector that's orthogonal to the plane, then that's what A, B, and C is. X, Y, and Z are just variables. And then the last thing we have is X naught, Y naught, Z naught. Remember that was a point in the plane. So the 2 things we need for a plane, if we were going to write it down, is we need a point. We also need a normal vector. So it's not one that's parallel, it's one that's perpendicular or orthogonal. There's another form for this line if you were to distribute everything out. So I'll do that here. Notice, okay, remember that x, y, and z are variables, but the naughts, x0, y0, and z0, those are not variables. Those are our constants. So what we're going to do is we'll take every one of those constants, we're going to put it together and give it a new variable name. So I write down what's left, ax plus by plus cz, and then I have this d here, and we're going to say minus d. So this other form, I'll write it down. We usually, books do it differently. Sometimes they have the d on the left side, sometimes they have it on the right. This is called general form. We are going to see both. You need to know both. All right, so here it is, generalized force, or in a nice pretty box, I guess. We wrote down exactly what's here. But there it is in a nice pretty box in case you need to reference it.